Section 3, Unit 2, Layout. Importance of engineering drawings. Layout processes of marking a workpiece to guide machining operation. Helps to know where to machine and helps obtain the maximum number of parts a piece of stock can make. Layout fluid. Coating with layout fluid dye makes it easier to see layout lines. It provides contrast, usually colored dark blue or red, and layout fluid remover. So layout lines provide guidelines for machining. Simple layouts, accurate down to 1/64 of an inch. You use a scriber, a combination set, dividers and trammel, prick and center punches, hermaphrodite calipers, plane protractors, surface plates, and surface gauges. A scriber in use. Notice the tool is tilted so the tip touches the guiding tool. Layout of perpendicular lines using a combination square. Layout of angular lines using the square head and protractor head from the combination set. The base of each head is held against the reference surface and the blade is used to guide the scriber. Finding the center of a cylindrical part using the center head and the rule of combination set. A divider is most frequently used to scribe a circle and arcs. Semi-precision layout. Trammel being used to scribe a large circle. A prick and a center punch. Note the difference in the angles of the points. So the left will be a prick, the right will be a center punch. Setting a hermaphrodite caliper rule, or with a rule, so you'll latch it on the end here and you'll adjust it to whatever width you want. Then you'll scribe a line parallel to the edge with a hermaphrodite caliper, keeping the guiding leg at a constant height along the edge so the scribe line is straight and drag the scriber point. A plane protractor being used to lay out an angular line. The head is held against the reference angle or edge and the scriber is guided by the blade. Surface gauges are very versatile because of their ability to be adjusted to several different positions. The scriber can be mounted to the spindle with a clamp or directly mounted to the base when working close to the surface plate. The fine adjustment knob can be used for fine tuning and setting after clamping the spindle and or scriber. Setting the height of the surface gauge scriber with a rule and rule holder. Note that the tip of the curved end of the scriber is parallel to the surface plate. Scribing a line with the surface gauge, so you just put it up there and slide it to make a scratch. Scribing a line parallel to the surface plate using the angle plate. And some different types of parallels and setup blocks that can be used to steadily secure your workpiece during layout. Some uses of a V-block when performing layout. So you just got it clamped in there so where you can scribe the lines. And on the right you got a V-block so you can do it at a 45-degree angle. For more accurate layout work, tools, you got a height gauge, a vernier beveled protractor, and sign tools. So scribing lines with a vernier height gauge, a vernier protractor being used for precision angular layout, and a sign bar holds the workpiece at the desired angle while the height gauge scribes an angular line. So these are going to be a little bit more precision than the other. Alright, finding dimensions or locations not specified on a print. Dimension X, Y, and R, radius are given. Laying out a 90-degree arc tangent on two perpendicular lines. Establish the radius center point. So, first you know the radius of the plane. You'll scribe it on the top and the right. Set the divider of the scribe arc. So pretty much you'll put it from the center and then you'll set it there, then you'll scratch a line all the way across. And establish the radius center point. Set the divider and scribe arc. Alright, laying out two 90-degree arcs on a tangent to each other. So you'll use that pretty much the same thing. You'll make some reference edges, lay out the two arcs, and then find the center of them. Then find your starting points and then scribe your line from each one of those. Alright, a divider can be used to construct a hexagon inside a circle. After scribing the circle, keep the divider at the radius setting and walk around the circle. Then connect the intersections to form the sides of the hexagon. The diameter of a circle inscribed in a circle, the diameter of a circle inscribed in a square is equal to the outside dimensions of the square. If a circle is to be cut from a square-shaped material, the outside dimension of the square must be equal or larger than the diameter of the circle. When a square is used to cut a circular workpiece, the diagonal distance across the corners must be equal to or less than the diameter of the circle. Bisecting the square into a triangle can be used to determine the diameter of the circle needed. A bisected square results in a triangle with interior angles of 45, 45, and 90 degrees. If a diameter is known, the largest fitting square may be determined by multiplying the diameter by 0.7071. If the desired side is known, the largest fitting diameter may be determined by multiplying a side by 1.414. A divider being used to construct a square within a circle. So you got the start point. Make this arc from start point to create point number 2. Make this arc from start point to create point number 3. And then make this arc from point 2 or number 3 to create point 4. After 4 points are established, connect them to create the square. A square being constructed on a circular workpiece using center lines created with a center head. First set of parallel lines offset from the center line. Perpendicular center line created with a square. And second set of parallel lines offset from center line. A square being used to create a line perpendicular to a straight workpiece edge. Parallel lines may be created at the desired distance from these two lines. A workpiece with no square edges using a line as a reference and a square to create an adjacent perpendicular line. These two lines may be used to create parallel lines at the desired distance for each other sides of the square. General steps. Study the engineering drawing and develop a process plan and steps and tools that will be used. Keep tolerance in mind when selecting layout tools. Make sure that the part is deburred and layout dye has been applied in the areas where layout will be performed. Decide on reference angles or edges and or layout baselines. These are the surfaces or lines for which all other measurements will be taken. General steps continued. 4. Lay out the center points of any circle or arc. A prick punch can be used to lightly mark these center points. Construct circles or arcs, scribe angular and tangent lines, and then scribe lines to connect any remaining points.